A dying star explodes with the energy of 1,000,000 billion suns, creating some of the strangest objects in the universe, and you're about to learn how in this video. Stars make energy by fusing hydrogen into helium, but once all the hydrogen is used up, the star's death begins. There are 3 ways a star can die, depending on its mass. Low-mass stars like the Sun run out of hydrogen after 10 billion years. The core is too cold to fuse helium. Without outward pressure from fusion, the core collapses under gravity. The collapse is stopped by quantum forces between the tightly packed electrons, but the heat from the collapse triggers fusion in a shell of hydrogen. Energy production soars, making the upper layers expand to giant proportions. If the Sun were this size, even Mercury and Venus would be consumed. As the star expands, the surface cools and turns redder. The first red giant phase lasts 1 billion years. But eventually, the core gets hot enough to fuse helium into carbon. Suddenly, the helium core ignites with the energy of 1 billion large nuclear bombs. The additional fusion pushes against gravity, making the core expand and cool, which, ironically, makes the star shrink and heat up. This takes about 10,000 years. With extra fusion, the core now burns much faster, taking just 100 million years to fuse into carbon. But the core is too cold to fuse carbon, so, like before, it collapses, and the heat from the collapse greatly increases fusion, making the star become an even bigger red giant, even engulfing the entire Earth. The hydrogen shell fusion produces helium ash, which builds up and fuses explosively. This cycle continues for 20 million years, creating violent thermal pulses. The pulses fling the star's gas layers into space, leaving behind the hot, dense core. X-rays from the hot core strike the gas layers, causing them to glow. They are called planetary nebulas, nothing to do with planets, but the gas eventually makes new stars. The remaining core, mostly made of carbon, is called a white dwarf. At the size of the Earth, but with 60% of the Sun's mass, 1 sugar cube of the white dwarf would weigh 1 ton. Over trillions of years, the white dwarf slowly cools down to form a brown dwarf. Now let's look at medium mass stars. Higher core pressures mean heavier stars fuse their hydrogen into helium much faster. Like before, the helium core collapses, triggering shell fusion, and eventually starts fusing helium. The star now expands into a helium-burning supergiant. At 500 times bigger than the Sun, it would even consume Mars. Over a few million years, carbon ash builds up in the core. But the higher pressure means the core does get hot enough to fuse carbon into neon. The extra fusion makes the star grow even bigger as a carbon-burning supergiant. At 1,000 times the Sun's radius, it would even engulf Jupiter. Over the next million years, neon ash builds up in the core. Eventually, the core gets hot enough to fuse neon into oxygen. Oxygen ash builds up over tens of thousands of years, and eventually gets hot enough to fuse into silicon. Finally, silicon ash builds up and fuses into iron. As iron builds up, the core now resembles an onion. Energy production is enormous, making the star expand to 5,000 times the Sun's radius, even engulfing Saturn and Uranus. But this is the end. Iron can't produce energy by fusion. When the iron grows to 1.4 times the Sun's mass, gravity is so strong that not even quantum forces can support it. In a split second, the iron ball collapses from the size of the Moon to the size of London. The protons and electrons get so close that they combine into neutrons, also releasing a neutrino. The neutrons compress until it's stopped by nuclear forces, creating a dense neutron star. The outer layers of the core hit the neutron star at 23% light speed, sending back a powerful shockwave. Neutrinos emitted from the inner core propel the shockwave to 10% light speed, causing the star to explode as a giant supernova with the energy of 3 million billion suns. Some of the neutrons blasted outward by the shockwave are absorbed by large nuclei, creating heavy elements like gold, lead, and uranium, crucial for life. These elements are then flung into space. The remaining neutron star is incredibly hot and dense. 1 teaspoon would weigh as much as Mount Everest. They produce extreme magnetic fields as they spin, firing powerful jets of charged particles that sweep through space. From Earth, they appear as pulsars. Finally, let's look at high mass stars. These die in a very similar way to medium mass stars. But this time the core is over 3 times the Sun's mass. The implosion is now so powerful that the core collapses to an infinitely small point. Gravity curves space-time so much that not even light can escape, and a black hole is created. With 3 solar masses packed into an 8-kilometre ball, they are the densest objects in the universe. So these are the 3 possible ways a star can die. Please like and subscribe for more content.